Hey everyone, this is Brent Sullivan. Today I'm talking about Java's ClassPath, and I wrote a lengthy blog post about this, but figured I'd record a screencast too. So let me know what you think in the comments below. I'm over in the editor here, and I've got a demo directory, and inside of that directory is just a Pizza.java file, which contains a class definition. It's very boring, it doesn't do anything quite yet. So let's go over to the terminal and compile this. So javac pizza. And I know that compilation succeeds because a class file pops out. Let's clear out the class file, and let's go back to the terminal, and let's compile again, this time with the verbose flag. And let's inspect the output really quick. So the first thing the compiler does is parse Pizza.java, and then it outputs this line. And this is the search path for source files, and it's the current directory. So everyone, this is the class path. The compiler is telling us where it's searching for sources and class files. It's also searching for class files in a bunch of different locations. And I'll tell you right now that this is the most important one. This is the rt.jar, the runtime jar, and you'll see why in just a second. Let's keep on inspecting the verbose output. So the next thing that's interesting here to me is that the compiler is going to load object.class from rt.jar. So remember when I said to keep this in mind, here's runtime jar, and object.class lives inside of it. Okay, so the compiler does some higher level checking of the pizza source. It loads some more stuff from rt.jar. There's rt.jar again. And then finally, compilation succeeds, and the compiler writes pizza.class. So this output is very interesting, but it's also very long. So what I'd like to do is start to simplify this output so that we can draw meaningful conclusions about the class path as this video progresses. So let's go over to this file, and what I've done is break up the javac command and add a bunch of options and just split them up over multiple lines so that they're easy to read. So I've got my verbose flag, and I've got the class path option, and I just put some quotes after it just to zero it out. I've got extdirs, I've got that zeroed out, and I've got bootclasspath zeroed out. And how did I know to zero out both of these things? Through some trial and error, but it's also more or less obvious in the output, and you can check that out in my blog for how I found those things. But just for this video, I'm going to copy this command and go back to the terminal, clear it out, and execute again. And you'll see that I'm getting sort of the same output, parsing Pizza.java. Here's my class path, and here's the output corresponding to the extdirs, so corresponding to these two options, is where the compiler is searching for class files. And I've just zeroed that one out too. I've just said, oh, only search in the current directory. But then I get an error. It says unable to find package Java lang and class path or a boot class path. So I have to add jar containing java.lang. Remember when I said to remember rt.jar? Well, rt.jar is the one that I need. So I've got that down here in my file. I'm just going to add this to my boot class path. Let's go copy this command, go back to the terminal, clear this out, paste, run it again. Okay, so now this is a lot nicer. Here's the output. So parsing, or here's the verbose output. Parsing Pizza.java, here's the class search path, it's still just the current directory, and here's the extdirs and boot class path. It includes rt.jar and still the current directory, and now this is just the verbose output. So it's much shorter now, it's much easier to read. So we load object.class from rt.jar, check pizza, load some other stuff, and write pizza. So much simpler now. And the reason that I bring this up is because this is going to be my home base for the rest of the video. I'm going to be adding on to this command for the rest of the video. So this is the simplest I could possibly make the verbose output by adding in these options. So now what I'm going to do is start making my example just much harder and more complicated, just to show what role the class path plays in compilation. So let's go now to the editor and clear out the class file, and let's add a dependency here, sauce s equals new sauce, because all pizzas have sauce, of course. Let's add a new file, and let's just split this up down just so it's easy to read. Public class sauce Get rid of this. So now I can see pizza depends on sauce. No problem. Let's go back to the terminal. Actually, let's just take this exact same command, drop it into the terminal, compile again, and let's just run through the output really quick. So parsing pizza, so the compiler is parsing pizza.java. Class path is still unchanged, it's still just the current directory. The other search paths for class files, just rt.jar, and the current directory. And now the changes here that are interesting is now the compiler is loading sauce.java, it's parsing sauce.java, and it's writing sauce.class once compilation is successful. I haven't had to do anything yet with the class path. The compiler knows that like the current directory, if it contains the sources that I need, the dependencies that I require, then we're good to go. I haven't had to make any changes there yet. So what I'm going to do is just like keep on making this example more complicated to show how the class path changes. Okay, and now let's put both of these into a package. So let's go ahead and take our command and put this back in the terminal and compile again. And of course, the compiler doesn't know where Pizza.java is. I've moved it, right? It's in food machine now, so like I have to tell the compiler that that's where this thing is. Take the command, back over the terminal, just clear it out. Okay, and so now I get successful compilation. Usually people don't want to like output their class files in the same directory as their source files. So let's go back to the command and add a little flag, D, and just put the source files. We're going to tell the compiler to put the resulting source files in a directory called out, and this thing just says go to the next line. So let's go back to the terminal. Whoops, let's copy the command, go back to the terminal, clear the terminal really quick. Let's make a directory called out. You can see that's right. There's my directory. Clear this, paste the command. So the only thing that's changed here is the D option. Okay, and now let's go back over here, and you can see that both of my class files are now in this directory structure that mirrors my source package structure. I just want to inspect the verbose output really quick to make a point in just a second. So here's the verbose output. So we're parsing food machine Pizza.java, and the search path for source files is still the current directory. We haven't changed anything about where the compiler is searching for other class files, still rt.jar in the current directory. Okay, so it's still loading object.class, and this is where it gets really interesting. It has to go through the entire compilation process for both files again. So I've got regular file object, here it is, and I'm going to load sauce.java, and then I have to parse sauce.java, and then eventually I write sauce.java. But what if, suppose, sauce.java hasn't changed, and I go over here and I say make some change to, a little change that has nothing to do with sauce.java, but is instead just a change in this other class. Okay, so what I guess the point that I'm getting at is like I should not have to compile sauce.java again. In other words, like if I run this thing, I want to be able to just tell the compiler, go get sauce.class. Like don't go through the loading sauce.java, parsing sauce.java, and eventually writing sauce.class. Don't do any of that again. Like instead, just go get sauce.class. Like it hasn't changed in my source here. It's completely unchanged, exactly the same thing, but and so I should not need to compile it again. So how do we do that? We finally are going to make a change to the class path. So what I do here is just add the out directory to the class path. I'm telling the compiler, go search for class files in the out directory. So let's copy this thing, go back over to the terminal, paste, execute, and let's just check the output really quick. So what's different here? So we're still parsing food machine Pizza.java, and here's the thing, the first thing that's changed, first thing to notice, finally we've made a change to the class path, and here it is, search path for source files, out. So this turns out to be a slightly misleading statement. It's the class path is actually searching for source files and for class files, and it's searching the out directory for them. And so now let's keep going. So we're still loading the same rt.jar and out, and now instead, so here it is. Notice that there's no rote sauce.class. In fact, we're not loading, parsing, writing sauce.class at all. We're not touching it one bit. We're just loading it here for the benefit of pizza. So we load sauce.class, not sauce.java, sauce.class, just for the benefit of pizza. So you can imagine the savings here. So on the one hand, if we have not specified this out right here, if we have not told the compiler to go look through the out directory for class files, then the compiler is going to go load sauce.java, it's going to parse sauce.java, and it's going to write sauce.class. It's going to go through that whole process again. So not to belabor the point, but like you can imagine that like if you have tens or hundreds or tens of thousands, tens of thousands of classes, that the compile time savings here are like substantial. You don't have to load, parse, and then write each one of those class files again. You just say, oh, go get them. They're already compiled. Like everything's cool. Just go get them from here. So this is like a big deal. That's what the class path does. It says like search, for class files. You don't have to compile them again. Like that's pretty nice. Let's keep on making this like more challenging. So suppose now that I introduce an external dependency. Okay, and so what I'm doing here is I've got this boolean is prime, and it's going to use this other package, com, Google, com, and math. It's going to use this class from Guava, essentially, and it's going to call this method on 3. And it just does the obvious thing. It just says, like, is this thing prime or not? The output doesn't even matter. I'm never going to run this, but like I just want to show like how this impacts compilation. So let's go back to the statement we've been working with the whole time, not make any changes, and let's go try to compile this. And of course, like compilation is exactly the same until the very end. Food machine pizza, Java line 6, error package com, Google, math does not exist. Okay, so like the compiler's like, I have no idea what you're talking about. You're trying to call this method on this class in this package, and like I have no idea what that is. Like you have to tell me what that is. So let's go back and actually add it. So let's do this. So now let's download the jar. Now back over here in the command that I'm working on, class path out, I need to tell the compiler where to search for the class files in this jar. So I add a colon. I need to go up 2 directories, and then I'm going to go into my downloads folder, and then I'm going to tell the compiler to look through this jar for the class file that I need. So let's copy this. Let's go back over here, paste, enter. And then we compile again, and you can tell that this succeeds because we write pizza.class at the end. In other words, like I was able to tell the compiler successfully where this package is so that I could use this class and this method on this class. And that's the whole deal with the class path, is that I tell it where to find sources and classes. And in this case, I had to include the directory qualified, this is like an important thing, the directory qualified jar file that contains this class. I had to go tell it where to get that stuff. So just, summarizing, this is pretty much the end. Like, here's my Java compiler command, verbose output. This is where I should put my class files after compilation. And then the most important thing here is that I'm telling the compiler to go search the out directory for source files, or for class files, and then I'm also telling it, using colon separation, to go search through this jar for other class files that I need. And that's the whole deal with the class path.